Okay, hello, this is C Mathematics, and today we're back on Argand diagrams, which is Core Pure 1 Chapter 2. So I've been requested by some people to go through some questions, specifically requested from physics and maths tutors. So we've got some questions here. We've got question 2, 4, 6, 8, 7, 8, 10, and 11. So we've got these questions. I'm just going to be working through them today. So let's just get started. So we've got this first question over here, question 2 on PMT. So we're given that there are two complex numbers z that satisfy this, and we have to find the range of values for r, and r is a real constant and r is this over here. So let's just break down the first bracket. So we've got the modulus of z minus 3 minus 5i, so we can rewrite this as the modulus of z minus z1, which will be 3 plus 5i, and it's equal to 2r. Well, we know from our loci that this is a circle centered 3, 5 with radius of length 2r. Well, if we see here, we're going to be intersecting with this, and we've got arguments, that's going to be a half line. So we're intersecting, and we'll have to find like a range of values for r. So what we're going to have to do is we're going to have to equate the equations, but to find the equations we have to convert to Cartesian. So this implies that we have x minus 3 squared plus y minus 5 squared is equal to 2r squared, which is 4r squared. So this is our circle. Now the second bracket over here, we've got the argument of z minus 2, so we can rewrite that as the argument of z minus 2 plus 0i, and that's equal to 3 pi by 4. Well, we know again from our loci that this is a half line from the point 2, 0, and it's at an angle of 3 pi by 4 from the point 2, 0. Well, we know for half lines the gradient of the half line is tan of the argument, so we can say with gradient tan of 3 pi by 4, which is basically the same thing. It's at an angle of 3 pi by 4. Well, we can work out what this gradient is. So tan of 3 pi by 4 is minus 1. So what we can say is m is minus 1, which is tan of 3 pi by 4. So we can work out the equation of this line by doing y minus y1. Well, y1 is 0, and then we're going to get x1 is 2, so y minus y1, so y is equal to minus x minus 2. So y is equal to 2 minus x. Okay, so we have got equation of the circle and equation of the line. Now when we have an Argand diagram question, always just try and sketch. It is so easy, it makes things so much easier because you're able to visualize it when you sketch it. So let's just draw some axes. So we'll do something like this. Okay, so we have got the line y equals 2 minus x, but this is a half line. This is just the equation of the line. We've got a half line from the point 2, 0. So at the point 2, 0, it will be an open dot, and it's got gradient minus 1, so it'll be something like this. So the line will be something like this, and that's our angle of 3 pi by 4. So that's what we're going to have. So at the point, let's say this is 2, 0, so we're going to have an open dot. So I'll just draw it here. So we've got an open dot, and then we're going to have a gradient of minus 1. So something like this. There. Well, now we've got a circle centered at 3, 5. So well, this will be 3, and we'll say, and not to scale, so we'll say this is 5. So our center is going to be over here. So we're going to have a circle. Now we're told, now we don't know what r is. All we know is that the radius has length 2r. Well, we don't know what r is, but we are told that there are two distinct complex numbers z which satisfy this, and this is the intersection of them. So they're going to intersect, so we're going to have this circle, but it's going to intersect, so it's not going to be that small. We're going to have 2 points of intersection because there are two complex numbers z which satisfy it. Well, if we draw the circle, this is when the line is a tangent to it. After this point of tangency, we're going to have two solutions. It's going to be a chord to the circle, or a secant. Then over here, this is the maximum value of the radius, because that's the last time we can have two solutions. When we increase beyond, then we're only going to have one point of intersection. And this because the half line, well, we can see it's only from the point 2, 0. So the point 2, 0 is here, so the circle intersects 2, 0, and that passes through the line. But then as we increase past 2, 0, we have one point of intersection. So basically we're going to have the value of r past this point of tangency, so we're going to have to find the radius at this point of tangency, and then we're going to have to find the radius at this point over here. So this is the maximum value of r. Well, first let's find the distance from the centre, which is 3, 5, to this point over here. Well, that was when the line was a tangent to the circle. So we know that if we make it intersect, well, we've got the equation here, we've got the equation here, we can sub in y over here. We'll get a quadratic, then we're going to, because there's one point of intersection, we're going to do b squared minus 4ac equals 0. Then we're going to find the value of r, and the inequality will be excluding, because we don't want the point of tangency, we want when there's two solutions. So it's just going to be an excluding inequality, so something like that. Then for this is the maximum it can be, because as it increases beyond this point 2, 0, this will continue to have a point of intersection, because the circle will just get bigger, so it will go along this line. So it will intersect along that part of the line, but the line just stops here, it doesn't continue there, it doesn't continue there. So the circle is just going to keep expanding here. There'll be no point of intersection here, but there will be along this point of the line. So basically, we want to find the point of tangency, and then we want to find the distance over here. So what's this distance of the radius? And that is going to be our value, and that's going to be our range for r. So first let's find, so this is going to be easier to find because we've got this 3, 5, and then we've got this 2, 0. So we can find this distance over here, so the maximum value of the radius, so max value of radius. We're finding the distance between 3, 5 and 2, 0. Well, this is going to be 3 minus 2 squared plus 5 minus 0 squared. So that's all square rooted, and this is the square root of 26. So that's the maximum value of the radius. Which is this. So this length over here is the square root of 26. Oh, but our radius was 2r, so that's equal to 2r. So r is equal to root 26 over 2. So this is our maximum value of r, because that's when we're reaching this point over here. Now we have to find the minimum when this is just a tangent. Well, for that we're going to equate the two equations. We're going to equate this, and we're going to do b squared minus 4ac is greater than 0. So when we find the minimum value of r, of 2r, we'll say, well, we intersect, so we're going to get x minus 3 squared plus y, which was 2 minus x, and then minus 5 squared equals 4r squared. So here we're going to get x squared minus 6x plus 9 plus, okay, this is minus x minus 3 squared, so we're going to get plus x squared plus 6x plus 9, and that's equal to 4r squared. Well, we'll minus 4r squared, make it equal to 0. So minus 6 plus 6 cancels, so what we get is 2x squared plus 18 minus 4r squared equals 0. We can simplify this, so we'll get x squared plus 9 minus 2r squared equals 0. So this is our quadratic that will give us the point of intersection over here, when the line is just a tangent to the circle. So to do this, we're going to set b squared minus 4ac equals 0. So what we're going to get? Well, b squared, there's no b term because there's no x term, so it will be 0, minus 4 lots of 1, lots of 9 minus 2r squared. And that's going to be equal to 0. Well, that's going to be minus 36 plus 8r squared, so 8r squared minus 36 equals 0. So now we're going to divide by 4, and then we're going to add 36 over 4 to both sides, so we're going to get 2r squared equals 9. So r is going to be plus minus square root of 9 over 2. And it's not going to be the minus because r is the radius. So we can put is not the negative square root of 9 over 2, as r is a length. So we're going to get 3 over root 2, which is 3 root 2 over 2. So that's the minimum value of r. So our range of values for r is going to be bounded between the minimum, not including, and the max. So therefore, we're going to get r is between 3 root 2 over 2 and root 26 over 2. This should be our answer. So let's just see over here.